Okay, so here we're looking at 3.1, solving systems of equation. I went ahead and wrote down the steps that I feel would help, and then I'm actually going to show you an examples after we look at some characteristics. So you may have to pause it, write this down, because I'm moving on. Here we have characteristics of linear systems. The first one, which is A, has two lines that are parallel. So I'm just going to write that graphically, they would be parallel. B, graphically, that would be one line or the same line. And then C, graphically, that would be intersecting lines. Now let's actually label these. So let me erase this. Hello. Okay. So for A, when you have parallel lines, that means it's inconsistent. For B, it's going to be consistent because they do have some solutions. But when they have solutions, because there's so many solutions, that one answer of one line depends on the other line because they're the same line. So this is consistent and dependent. On C, because there is a solution, it's consistent and they intersect, so they are independent of each other because they're two separate lines. Now I do want to add one thing. When you are looking at these graphically, we've already discussed it graphically. It was, let's see here. This one would be parallel lines, this one would be the same line, and this one, C, would be parallel lines. Now let's look at it algebraically. Algebraically, you would actually get, for inconsistent, you would get a number that does not equal another number when you go to solve, and I'll show you how to solve in the next slide. So these would be not equal to if you were solving algebraically. And that's what I want you to do in this lesson. I don't want you to graph it. I just want you to do it algebraically and then use these notes on this slide to decide what it would look like if you had to graph it. All right, on B, algebraically, you would end up with one side of your equation equaling one side of the other side, which we call many solutions. This one we would call no solutions. And then consistent independent, what would happen is you're going to end up with an ordered pair. You're going to end up with an X and a Y. You would actually solve for those, and that would be one solution. So that would be the main part of what's going on here. The one solution would be that ordered pair right there. The examples in this slide here. With this example, we want to go ahead and line it up. Now you've already written the notes, so we want to go ahead and line up our X's. So and our Y's, the X's are lined up right here, but the Y's are not lined up. There's the equals and they're not even lined up either. So let's go ahead and move things around. Let's move that 4Y, my bad, over to 6X. So 6X minus the 4Y is equal to 30. The second equation, I'm leaving it alone since the X and Y are on the same side. Now I'm going to go ahead and look at my goal, which is to multiply one of them or both of them to get opposites. I'm going to go ahead and, what did I decide to do here? I'm going to multiply this whole top one by -2 because my goal is to get rid of the x's. And in order to do that, I need opposites. So let's see what happens. I'm going to multiply the top one by -2. And I'm going to just bring that down here because I don't have room to the side where I normally do it. So that gives me -12x, a positive 8y, and a -60. So now I'm going to go ahead and add these two. I'm going to add these two systems. So when I add them, I end up with 0 here. When I add these, here I'm going to end up with, because these cancel, I'm going to end up with 13y's is equal to -78. When I divide by 13 to both sides, I get a y value of -6. So that tells me, because I end up with a y value, I do not have no solution. I do not have many solutions. I actually have a one solution. So this is going to be a consistent independent. Without even me graphing it, I know that much. So right now, I know my ordered pair is going to be something, comma, -6. Let's figure out what the x value is. If this was multiple choice, I would find my y value be -6, and then that would be my choice. But it's not multiple choice. I keep going. So now I'm going to go ahead and substitute this value in for y in one of my equations, whichever one looks easier. I'm going to go ahead and substitute it in the top one. So I just don't want that there. Well, that's supposed to be an x. Sorry, it looks so weird. -4 times -6 is equal to 30. So I'm plugging it back into that value right there. So I have 6x plus 24 equals 30. 6x equals 6. When I subtract the 24, so I get x equals 1. So there is my other solution. So an ordered pair is made with an x, comma, y. So there is my answer. 1, comma, -6. And then to review the vocab, you can say that this is consistent and independent, because they intersect two separate lines. And if I can spell independent, that don't look right. Thank goodness for erasers. And consistent, independent, that means there's just one solution. If I had to graph it, which I don't want you to graph this section, these would be intersecting lines. All that good stuff, they all correlate. This concept, consistent, independent, intersecting, one solution, all go with this 1, comma, -6. So if they ask to describe it, those are the descriptions, those bulleted items. If they just want you to solve it, then it's just 1, comma, -6. Okay, let's go on to our last example. Here's our last example. We're going to go ahead and get the x's and y's lined up. Oh, wait, it's already lined up. Everything is lined up. So the next thing is to go ahead and look at our goal to eliminate one of the variables. I'm going to go ahead and just eliminate the first one. It don't matter which one you eliminate. So I'm going to multiply the top one by -3. And sometimes you would have to multiply both of them, but in this case I don't. So that's going to be -6x, -9y, -15. The bottom one I did not mess with, so I'm just going to bring it over. I did not have to multiply it by anything. So now I'm going to go ahead and add these together. Since they're already opposites, this part right here is opposites. So when they're opposites, they cancel out. Oh, this cancels out too, We got 0 equals 0. When the same number equals each other, I'm going to stop. I'm going to say this is many solutions. And without graphing it, I know that these are going to be parallel lines. Which means it's going to be consistent, because there is a solution. Matter of fact, there's a lot of solutions. Consistent, dependent. And if I were to graph it, oh, wait, whoa, not parallel lines. I don't know what I'm talking about here. Not parallel lines. Parallel lines means there's no solution. This one's many solutions. This one means that it's the same line. If I were to graph it, consistent, dependent, many solutions. So my final answer is going to be many solutions. If they ask me to describe it, that would be the same line, consistent, dependent. All right, guys. As always, ask questions if you have any of them in class tomorrow, and I'll talk to you later.